Welcome back to more in our discussion about logarithmic functions and equations. And in this video, we are going to discuss how to solve logarithmic equations using the one-to-one property. Now, this is a great property to employ, especially when all that is in the equation are logarithmic expressions. Let's go back to this idea of a one-to-one function. When you have a one-to-one function, that means that every input has exactly one output and vice versa. Well, what that means is if I can write an expression like this, a single logarithm is equal to a single logarithm, and each of those logarithmic expressions have the same base, well, if I can say a single log is equal to a single log, not the single ladies, just the single logs, then we can drop the logs altogether and we can equate the arguments. So just like in the other technique, if there is more than one logarithm on a side, we first need to condense the logs so that it is written as a single logarithm, and we want to make sure that we check our answer in the original equation and make sure that our proposed solution actually satisfies the equation. We would definitely want to reject any solution that generates a non-positive argument. This is another case where we want to stay positive. Okay, so let's try a couple of examples. All right, so I've got a couple of examples here. And we're going to start out nice and easy with this first example. Log base 3 of the quantity 5x minus 1 is equal to log base 3 of x plus 7. All right, so notice that it is written in the form where we have a single log is equal to a single log. Okay, and so we are ready to rock and roll. That means I can just drop the logs altogether and equate the arguments. So 5x minus 1 is equal to x plus 7. So I want to go ahead and bring all my variables to one side and all my constants to the other, since what I have is a linear equation now. And I would end up with 4x is equal to 8, which would mean that when I divide through both sides by 4, I would get x equals 2. Now, just like any logarithmic equation, you must check and make sure that 2 actually satisfies the original equation. So go ahead and sub that in and let's see what we see. If you sub in that 2 in every place there is an x, notice that I've got log base 3 of 5 times 2 minus, which will be log base 3 of 9. And we want to know if that's equal to log base 3 of 2 plus 7. Which is also log base 3 of 9. And we know that log base 3 of 9 is 2. So 2 is equal to 2, which means we have a good answer. So in the next example, notice that on the left-hand side of the equation, there are 2 logs. Well, I can't use this single log equals single log thing because there are 2 logs. 2 is not the same as 1. So I need to take that left-hand side and condense this into a single log before I drop the logarithms. Okay, so let's do that. Remember that if I have 2 logs with the same base and I'm adding them together, that's the same as taking the log of the product of the arguments. So I can just multiply these arguments together and write it as a single log. Now notice here, I actually have 2 logs on the right-hand side as well, right? I've got 2 ln of x. That's 2, not a single log. So you might be tempted to divide both sides by 2, but then actually I have a coefficient of 1/2 on the left-hand side. So what we're going to do here instead is just shift this and write it as a power of the argument. Remember, we can do that using the power rule. Okay, so now I have it in the right form. I've got each side written as a single log, and so I can drop the logs and equate the arguments. So I'm going to have this x minus 2 times 2x minus 3 is equal to x squared. And let's go ahead and multiply this out as I rewrite it. So if I multiply this out and distribute, I've got x times 2x, x times negative 3, negative 2 times 2x, and negative 2 times negative 3, which translates to 2x squared minus 7x plus 6 is equal to x squared. Now, this is a little different than a linear equation because it's quadratic. Anytime you have a quadratic equation, you want to set it equal to 0. So this x squared on the right-hand side, we want to subtract that from both sides. So this right side is equal to 0. And we would have the result of x squared minus 7x plus 6 is equal to 0. I can solve this by factoring. And I would say, well, that's x minus 6 times x minus 1, and that is equal to 0. And then I would have two potential solutions. X is equal to 6 or x is equal to 1. All right, so let's go ahead and see what happens when I substitute these in. Let's try the first one first. Let's try x is equal to 6. When I sub this in, I've got ln of 6 minus 2 plus ln of 2 times 6 minus 3. And we want to know, is that equal to 2 times ln of 6? All right, so let's think about this here. What is 6 minus 2? This argument ends up being 4. That's positive, that's good. And this argument is 12 minus 3, which is 9. So I got 4 ln of 4 plus ln of 9. And remember, that's the same as ln of 4 times 9. So ln of 36. And then over here, I've got 2 ln of 6. But remember, I can write this as ln of 6 squared, which is ln of 36. And so this does actually work. We can say that the 6 does satisfy our equation. Let's try the 1. If I sub in a 1 there, I've got ln of 1 minus 2 plus ln of 2 times 1 minus 3 is equal to 2 times ln of 1. Now, if I combine these and simplify the argument here, I've got ln of negative 1. That's a problem because I can't take the ln of negative 1. Okay, and that is true for this second logarithm as well. What that means is x equals 1 is not really a solution. Only x equals 6 is a solution in this case. This is why it's really important to check your answers, because you can get answers through this process that don't actually satisfy the equation. We've got to check. Okay, we're going to do one more example. Here we go. Log of x plus 5 is equal to the log of x minus 1 minus the log of x plus 1. Okay, so remember that we cannot drop the logs until we have this in the correct form. Remember, we've got to have a single log is equal to a single log. So if that's true, I need to condense where I see 2. So if I have a log minus a log, then I can take the arguments and divide them. So I can write it as a single log with a quotient of these two arguments. Okay, so I've got log of x plus 5 is equal to the log of x minus 1 divided by x plus 1. Okay, so now I have a single log is equal to a single log. So now I can drop those logs and equate the arguments and then solve the resulting equation. Okay, so I have the equation x plus 5 is equal to x minus 1 times x plus 1. Okay, so to proceed there, I would want to get rid of that x plus 1 in the denominator by multiplying both sides by x plus 1. So if I do that, the left-hand side just becomes x plus 5 times x plus 1, and the right-hand side just becomes x minus 1. Now go ahead and multiply that left-hand side through. You should get a quadratic. You should get x squared plus 6x plus 5 is equal to x minus 1. And remember, when you have a quadratic, the highest power of x will be at x squared if it's a quadratic. We want to set it equal to 0. So let's subtract x on both sides and add 1 on both sides. And our resulting quadratic will be x squared plus 5x plus 6 is equal to 0. Now I can go ahead and factor that. And when I factor that, I get x plus 3 times x plus 2 is equal to 0. And then I can set each of those factors equal to 0 and solve, which means I would have potential solutions of x is equal to negative 3 or x is equal to negative 2. All right, so now we need to check. Let's go ahead and substitute the first one into our original equation. If I do that, I'm subbing negative 3 in everywhere I have an x. I'm subbing the negative 3 in here and here and here. I've got the log of negative 3 plus 5, which is the log of 2. Is that equal to the log of negative 3 minus 1, which is negative 4? Ooh, problem. Minus log of negative 3 plus 1. Ooh, another problem. Okay, so those two are problems, which means x equals negative 3 is not a solution. So let's try x equals negative 2. Okay, we want to know, is the log of negative 2 plus 5 equal to the log of negative 2 minus 1 minus the log of negative 2 plus 1? And I'm sure you can see right away that we have similar problems. That second and third log, they both generate negative arguments, and so x equals negative 2 is not a good solution either. And in fact, this equation has no solution because our proposed solutions don't satisfy the original equation. So hopefully that reinforces the idea you must check your proposed solutions to see if they actually work. Okay, in the last video of this sequence, we will be talking about applications of logarithmic functions, and I will see you then.